This is an F1 car, and it is by far one of the greatest inventions mankind has ever made. It is a different breed of car with a single seat, an open cockpit, turbocharged engines, front and rear wings. F1 cars have gone from simpler, smaller designs with engines mounted at the front to lighter cars due to metallurgical advancements. From the addition of wings to reduce ground effects, to introduction of turbocharged engines, to the introduction of carbon fibers for rigidity and strength, F1 cars have gone to speeds over 200 miles per hour, with engines pumping well over 1000 horsepower. Just thinking about it gives me goosebumps. These are cars that are pulling off what today's rockets are known for doing. Okay, but let's start with how Formula 1 cars actually came to what they are today. Earlier on, these cars had heavy steels, no aerodynamics to speak of, and front engines. But now, these F1 cars are like nothing we've ever seen before. Things have evolved fast. Several things have changed, like adding a rear engine, making the cars handle better. Then came wings for downforce. And at one point, teams figured out a way to use the car's underbody to get sucked to the ground in order to be able to corner around the tracks at speeds that are way faster than ever, around 5 to 6 Gs. That is 5 times the force you feel on your body, and that's as much force you can feel on the surface of the earth. That is the force at which rockets take before they can escape the earth. Eventually, electronics started showing up too, with traction systems that could help the car have better grip. But the FIA, the governing body for these motorsports, eventually banned it because the F1 cars depended on the driver's skill. One of the biggest discoveries, though, was energy recovery systems, ERS. First, they introduced a system that grabbed energy from the car braking. When the car brakes, the car generates enough energy that could give the car a power boost that will give it a few seconds per lap in order to get ahead of a driver. Then that evolved to today's hybrid tech. But today, F1 cars run on 1.6 liter V6 turbo engines that use less fuel and are 50% thermally efficient, meaning more than half the fuel's energy actually gets used up. That's huge. There is less gas guzzling engines, and the weight of these cars these days are just under 800 kilograms, hitting 220 miles per hour. But to understand what actually makes these cars work, let's look at the components. Starting with the chassis, or as people say, the chassis, the core of the whole machine. It's made of carbon fiber, and for a good reason. It is super light, around 80 kilograms, but can handle 5 and 6 Gs during crash. They layer the carbon sheets with resin, baking it in an autoclave, but it becomes a survivor pod during crash. The fuel tank and impact structures. The impact structures are what help the driver from crashing, or brace the driver from impact to keep the driver safe. Next is the power unit. This is the powerhouse of the F1 car. It is a 1.6 liter V6 turbo with hybrid energy recovery, like I mentioned before, pushing at over 1000 horsepower, and the engine revs itself at over 15,000 RPMs. As I mentioned before, in hybrid systems, there is energy produced or gained from braking when the car is moving, and this sums up to over 160 horsepower, giving the car boosts. It's a perfect mix for raw power and efficiency. Over 50% of the fuel's energy moves the car, so that means there is less heat wasted. That's better than most road cars by a long shot. And aerodynamics is where F1 gets really crazy. The F1 cars has a front wing and a rear wing, but the front wings control the airflow, which makes the car balance, while the rear wings and diffuser creates downforce, which is just like the weight of the car, and at over 120 miles per hour, basically gluing it to the track, and it can corner at around 5 Gs without flying off. There is one old feature in an F1 car that has still stuck till today, and that is the wooden plank underneath the F1 car. This wooden plank prevents the F1 car from staying too low to the ground. The FIA made a regulation of 10 millimeters maximum, and when it's above that, your car will be disqualified. So you can see that aerodynamics is like a constant arm race between teams. These teams are trying to squeeze out every edge they can get to get from 1 second to even half a second, or even like quarter of a second advantage, because the stakes are really high. Speaking of aero, let's talk about drag reduction system, DRS for short. It's like a flap at the rear wing, and they open up in specific zones on the track, cutting drag and speed by 10 to 12 miles per hour on straight lanes. You can only use it if you are like 1 second within the person beside you to give you that edge, and it's like a last ditch effort to win the race. It is turned off during rainy days when wet tires are used because of the driver's safety, because when it gets too fast, the driver may lose control. Up next, we have the tires. What are F1 cars without tires? Or what is any car without a tire? F1 cars use 3 main compounds: soft, medium, and hard. So you have these tires ranging from softest and grippiest to hardest but less grippy. The softest and grippiest tires can go really fast because of their grip on the ground, but these soft tires, believe it or not, can wear out pretty quickly within 30 to 40 miles. And while you have the hard tires, these tires can go as long as possible, but they don't have enough grip on the vehicle. So the FIA made a regulation that each car must use tires of at least 2 different kinds, ranging from the softest to the hardest, before the races end. So it's like the teams will form different strategy of the tires they will use in order to get the edge. It's like a chess game, but on 220 miles per hour. Also, the hard tires can go as far as 120 miles per hour, but the tires will heat so fast they can reach up to 1000 degrees. All these innovations over the years have been pioneered by F1 engineers. These engineers from teams had just one idea, and they implemented it, and it's actually ended up benefiting each team. But believe it or not, F1 is like this big ecosystem of people trying to actually get their car as fast as possible. But however, eventually these teams will end up, believe it or not, they will gain or pick up these tricks or strategies these other teams have already gained. So it's like a big science fair. It's a science fair. Okay, we talk about the components of F1 cars, but how are they actually keeping the drivers safe? One of the safety features is the halo. The halo is just like this forged rod at around 7 kilograms, able to handle weight at over 12 tons of force. This halo, it is pretty significant in the driver's cars, and for a good reason. The FIA has made it mandatory for everyone to use halos on their cars, because it is, as every ounce of that halo is important. And now let's talk money. F1 cars are really hard to make, and that is why they are very expensive. No joke, you are looking at around $15 million per car. The power unit alone can cost $10 million. Aero development, another $2 million. The chassis, $700,000, and the gearbox also is going for around 500k. The FIA sets a cost cap at $145 million per team. However, the driver salaries are not included to keep things fair. It is as much a financial race as it is a tech one. Okay, let's step into the cockpit, the driver experience. How does it look like? Each driver has a custom molded driver cockpit made of carbon fiber. It's actually designed to fit like a glove. The drivers are basically lying down with their legs up almost at the eye level. This is, however, to maintain as low center of gravity as possible, and it's so tight in the air they can barely move, strapped with a 6-point harness to keep them safe, and the halo sits right above their head, and This halo sometimes disrupts their vision. And let's not forget the star of the cockpit, and that is the driving wheel. The driving wheel has over 20 buttons controlling different things like the DRS, the hybrid system, radio, and all while pulling around 5Gs in corners. So the drivers can't take their mind off the road. Even blinking for seconds can cause miles of darkness. If you don't know how long miles is, a mile is being in the dark for over 1,000 meters. So it's all about the driver's focus. But before these cars can even touch the track, they have to go through testings and simulations. Some are perfected in air tunnels where they can test the streamline of the body of the F1 cars when they go through the air. And these simulators are as accurate as they come. The teams use wind tunnels with over 60% scale models and with over 180 miles per hour to test the aerodynamics. You can see that these simulators are taking it to another level because they are trying to make sure everything is as accurate as it is on the field. Every turn, every bump, every shake is as much detail as possible to help the car, as I said, make it as fast as possible. The car itself has over 100 sensors in order to feed the simulators as accurate data as possible, so teams can tweak everything they can on the go, pit stop included. And you might be wondering, what is a pit stop? Well, a pit stop is like a really fast process where the cars are able to change all 4 tires in 2 to 4 seconds. It's really fast, all while the cars are going over 100 miles per hour with the pit stop included. And this pit stop include almost 40 crew members with at least 4 members per wheel plus jack operators. This is about the tires. These tires are pre-designed by the FIA because every car and team must follow the regulations. And no joke, the F1 takes this really serious. Any disobedience to the rules can cause an immediate disqualification. So as I mentioned earlier, the cars using the softest tires will be forced to use pit stop more because these tires weigh under 40 miles. Every strategy is like a team trying to outsmart the whole competition. So F1 isn't just about racing, and it has impacted the world around us, road cars included, from carbon fibers in F1s that are now used in supercars to hybrid techs from energy recovery systems that now power high-end road cars, and also paddle shifters, gearboxes in sports cars, and other safety features in F1 cars. And remember, using the car's underbody for downward force, and that's a very big idea. Everything in F1 innovations are being developed in road cars today. And as you can see, supercars, hybrid cars, even sports cars, there is advancement in each of them because F1 has tech that feels like they are like 5 years before road cars. F1 is like a tech lab on wheels because there is innovation every year. What's your favorite F1 innovation? Drop that in the comments. I'm curious. And that's for Formula 1 cars. Pretty insane, right? From carbon fibers to hybrid turbo engines to paddle shifters to rear engines to DRS, and that's it. F1 literally changes the game. I'm Yaza and I enjoyed breaking this down for you. If you like this video, please do hit the like button, hit a comment below what you would like me to post next, probably an engineering topic or something tech related. Thank you guys for watching, and I will see you in the next one.